Hey everybody, uh, here with another problem today. Gonna work on number 5 here, which is finding what the unit vector is of vector r. I don't know if you've encountered vectors yet. It's probably around, calculus 2, maybe calculus 1, when you start getting into vectors a little bit. Um, so, so this is typically how vectors wrote out. Um, The I and J and the K represent the directions of the vectors. So, like, you could think of it as I's in the X direction, J's in the Y direction, and K's in the Z direction. If you think of it on a three-dimensional axis. So this is something that I would have to go into and actually solve. It's kind of hard to see what the answer is without knowing exactly how to solve for it. So this is another way to write the vector r. So the up arrows or up carets represent vector um, directions, so they're just directional vectors, and the constants by the side represent the scale of the vectors in the corresponding directions, and the scalars are a, b, and c shown here. I've broken these down. So a is 12, b is negative 20, and c is negative 9. So the question is find the unit vector. So what is a unit vector? Well, if no unit vector and a normalized vector are the same thing. Basically, what a unit vector is just um, the original vector divided by the magnitude of the vector. So so knowing this, um, well, you think, well, what is the magnitude of the vector? What does that even mean? So that is, it can be described in three terms as a magnitude, length, or the norm of vector r. So the norm value is what we use to normalize the vector. That's where that terminology comes from. But basically, it represents the actual length of the vector point modeled in space, which is what this is. This would be like a vector point. And those are the individual directions of the point, or how to get to the point. Um, so the magnitude symbolize with these bars around them here. Um, so it's basically the square root of the sum of the squares of the scalars of the vector. Kind of a mouthful, but it's that's just how it's described here. So you plug it in, make sure you have your negatives with your scalars instead of um, out here in the equation, because that's actually the scalar value. They're just summed up. So you plug all that in, come out and determine that that's 25. So then finding our hat here, aka the unit vector, you just divide each term by the magnitude. Then you turn your fractions into decimals to get the decimal value to match with the answers represented here. And as you can see, the value is found to be b. But I just want to kind of expand a little bit on the visual representation of vectors. Um, so you could think of the vectors, like I was saying here, the different directions. So I is with x on the x-axis, j is with the y-axis, and k is with z. So this is a three-dimensional axis, so z is like coming out into space. Like if this is y and this is x, looking down on the page here, then z is coming out of the page. But it's an isometric representation here, so that's how I've had to draw it, if that looks a little confusing. So this point is just a point in a three-dimensional space with point values a, b, and c. So that would be just the point in space represented by the scalars of the vector. And then the actual direction, or the actual length of the vector r from the origin to the point is represented as the magnitude. That might sound a little confusing because of the way it's represented here, but the vector is pointing out in that direction, but we don't really know how long it is until we put the equation together here. So how long it is to the point. I hope that helps. If not, looking at it in two dimensions only might help visualize, and then you can build from that understanding to get a better conceptual grasp of three-dimensional vectors. Yeah, just let me know if that's something you'd like to see, and I can get an example put together. All right, well, thanks everyone. Hope that helped. Bye.